All right, as we continue to look at linear equations, today we're going to talk about graphing a line using just our intercepts. So first off, before we can even graph a line looking at intercepts, let's remember what an intercept is. So let's see, if I look at my red line here, my y-intercept is where I cross my y-axis. So in this case, my y-intercept here is going to be 4. So it has the ordered point 0, 4, because a y-intercept is when x is 0. And if I keep going down here and figure out where it crosses my x-axis, then that would be my x-intercept. And at this point, it's at the point -2, 0. Okay, so let's maybe write that out. We now know that our y-intercept is equal to where the graph crosses the y-axis. So that's when x equals 0. And we know now that our x-intercept is where the graph crosses the x-axis. So that's when y is equal to 0. So these are really useful things. Because this is going to help us determine things when we're interpreting questions. That's really good. And really, these are easy points to graph. And a line just needs 2 points and then you connect it with a line. Super easy. Okay, let's maybe do some reading off of our green curve here. So our green line, we're crossing our x-axis at -1. So that x-intercept is equal to -1. And it crosses my y-axis at -2. All right, let's look at our blue line. So yes, vertical and horizontal lines are allowed. In this case, notice how I have my y-intercept is 6 and there's no x-intercept because it's always horizontal. So it'll never reach it. So for my blue line, there's no x-intercept. So that's a possibility too. It can happen. All right. Now that we know a little bit about it, let's maybe graph a line given the intercept. So if I want to graph a line, I don't know, let's say it has an x-intercept of, what numbers do I have here? 2, 0, and I have a y-intercept of, I don't know, -3. That'll fit on my picture that I've got, my graph that I have here. So let's draw the dots and make a line. So x-intercept, so we go to our x-axis, remember that's this one. Intercept is at 2. And then my y-intercept, so remember this is my y-axis. I'm going through at -3. So once you have your dots, you get your line, connect your dots. And lots of students like to leave it like this, but that's just, no. The line is much further than just those points. So you want to extend your line through your points when you're making your graphs. And to be even more accurate, you really should have the little arrowheads on either end, because the line, unless I gave you endpoints, the line goes forever and ever and ever. Okay, so that's important. All right, how about using intercepts to graph a line? And this time we're going to look at an equation. So remember yesterday when we talked about standard form of the equation, this one, if we had converted it into standard form, would look like 2x minus y minus 7 equals 0. So the xy intercept form is actually not really that different. When I have the number on this side, this is in intercept form. And it's telling me some very important information right here. Okay, so in order to figure out my x and y intercepts, remember for my x-intercept, that means that y is equal to 0. So I'm going to take my equation, I'm going to sub in 0 for y, so it's gone. Well, let's just finish rearranging, divide both sides by 2, and x is equal to 3.5. So I can put a dot on my x-axis at 3.5. To figure out my y-intercept, y-intercept, remember that's when x is equal to 0. So start with your equation again, minus y equals 7. So when x is equal to 0, well, it's gone. So we're left with negative y equals 7. Divide both sides by negative 1 to get rid of that negative, and you're left with y is negative 7. So let's draw a nice little dot, negative 7. Set up our straight edge here to draw our line. And let's make sure we extend our line through our dots to be most accurate. Draw a couple of parts on the ends, a couple little arrows. There's one, there's two, and we got it. All right, same question, new equation. So we want to figure out our x and y intercepts and graph the line. So one way to do this is to move it into xy intercept form. So I'm going to subtract 15 from both sides. So you get 3x minus 5y equals negative 15. That's 5, by the way. Okay, and then for my x-intercept, I know that means y is equal to 0, so the y term is gone. So I have 3x equals negative 15. Divide both sides by 3. So x is equal to negative 5. X is equal to negative 5. For my y-intercept, I know that means that x now has to be equal to 0, so the x is now gone, and I'm left with negative 5y equals negative 15. Nice little one-step equations, eh? Divide by negative 5, divide by negative 5, and you get y equals 3. So y equals 3. So let's draw our line. Make sure we extend it through. So line up your ruler and then extend it up. And I'm going to just extend mine down. Hang on here. Wiggled on me. Good. And then make sure we put my end arrows in there. So I have, arrow, arrow. And if I want to check this, I can certainly convert that into our usual slope y-intercept form to check. Okay, now that we've done it in by graphing with our intercepts, let's just double check and make sure we did things right. So I'm going to do that by converting my equation now into slope y-intercept form, and we're going to see what it looks like. So let's convert our standard form, so 3x minus 5y plus 15 equals 0, into our y equals mx plus b form. And let's check and make sure we did it right. So to do that, let's see, we're going to minus 3x from both sides. So that leaves me with negative 5y plus 15 equals negative 3x. Okay, let's keep going. Now I want to move my 15 to the other side. Minus 15, so you get negative 5y equals negative 3x minus 15. Let's finish it off by dividing each term by negative 5. So that'll give me y equals, it's now positive, 3 over 5x plus 3. And let's confirm that by looking at our graph. So yes, we have a y-intercept of 3. And then let's look and see about our rise and our run. So I'm going to use my intercepts to draw my triangle, just because it works out so nicely. So I have a run of 5, because I came over 1, 2, 3, 4, 5. And I have a rise of 3. 1, 2, 3. So there you go. Rise, run, y-intercept. Got it. Nice. Here we have another example, and now I want to find the slope using my intercepts. So I'm going to look at my question here, and let's see what it says. I need to figure out the slope of the line, whose x-intercept is negative 4. So that means I have the point negative 4, 0, and a y-intercept of negative 6. So that means I have the point 0, negative 6. So remember, y-intercept x is 0. X-intercept y is 0. So to figure out my slope, let's do our, So to figure out our slope, let's use our slope formula where m equals y2 minus y1 over x2 minus x1. And because I used to always get these backwards, I'm going to start with 1 point. So there's my y value, there's my x value, minus, there's my y value and my x value. So let's simplify that. That becomes 0 plus 6 over negative 4. So that equals negative 6 over 4. Final answer, let's reduce that fraction. M equals negative 3 over 2. Okay, let's graph it and double check. So let's see, I have an x-intercept of negative 4 and a y-intercept down here of negative 6. Let's draw my line. Extend it through the points because we don't want it to just go from one spot to the next because then that just, oops, looks funny. Right, this is a full line. It extends all the way. And let's just check. Let's see. We needed our slope. So there's my rise. Here's my run. Let's count it out here. So 1, 2, 3, 4, 5, 6. So I went down 6. And I went to the right 1, 2, 3, 4. 4. Negative 4 over 6. And if I made my triangle smaller, I have a rise of negative 3 and a run of 2. So there's my reduced fraction. Nice work. Okay, so let's finish it off by looking at what's actually the very start of this chapter. So we've got Joanne here, and she loves reading. She's got $48 to spend at her favorite used bookstore. She likes comic books, which cost $4 each, and novels, which cost $6 each. And I'm not going to lie, I get into this kind of dilemma all the time. I'm an avid book reader from bookstores. So we need to figure out what kind of combination of comic books and novels can Joanne buy. So if we bought only comic books, well, I can take my total, divide it by $4 each, and that'll tell me how much I've got. All right, let's do that. So 48 divided by 4, so that's what? 12 bucks. Okay, so you can buy 12 comic books. Now, if we bought only novels, so let's look here, our novels are going to cost $6 each. So I'm still going to use the same total of $48. Let's divide it out by the 6. And how many times does 6 go into 48? 8 times. So I can get 8 novels. So these actually would end up being my intercepts. Interesting. So in this case, I'm going to let x equal to the number of comic books. So comic books are up here. My y is going to be my number of novels. So that's here. And write each combination as an ordered pair. So in this case, there's my x value. So that would be at the point 12, 0. And my novels would be at the point 0, 8. Well, that's really cool. Now let's graph it. Hang on here. Let me just scroll down a wee bit. So we're saying that x is our number of comic books, number of comic books, and we're saying our novels is on our y-axis here. So number of novels. So our y-intercept is at 0, 8 there, and our x-intercept is at 12, oops, here. So if I want to figure out a combination, well, how would I figure out those combinations? We can do a line. What? So I go from my y-intercept, which is novels only, to my x-intercept, which is comic books only. And this time I am definitely not putting arrows on this because I do have definite limits. So there are limits. So no arrows on the line. Okay, it's starting and ending at our axes. All right, so let's look at the combinations that are possible. There's a number of ways we can do this. We can see if we can't find some nice points on the line. Remember, if it's a part point, it's not going to count, right? You can't have half a book. One way to do this, we can look at our slope. Our slope could be really helpful. And why is that? Well, let's look. So if I had my slope of, let's see, I've got a rise, I've got a run. So if I just look at my total here, I had a rise of 8 and I had a run of 12. So if I reduce this fraction, so how many times does stuff go into here? Let's see, oh, if I divide that by 4, I would get a 2. If I divide that by 4, that tells me a 3. So now that nicely gives me the points along my line that'll be perfect. So I've gone down. So that means to find the next point, I go down 2 over 3. There's a dot. Down 2 over 3. There's a dot. Down 2 over 3. There's a dot. Down 2 over 3. Oh, good, we landed where we wanted to. So I could have a combination of 3, 6, a combination of 6, 4, and a combination of 9, 2. So that's one way to find, especially if you don't trust your line. I don't really trust my line. It's a little wiggly. It's a little hard to see. Okay, we could do this algebraically. So how would I do this algebraically? Well, I know that my total cost is going to equal to, let's see, $4 times my comic plus $6 times my novel. And we said that we had a total of $48. We're using X as our comic and Y as our novels. So there we go. We've got it in X, Y intercept right there. We can rearrange that if we wanted. We can solve out of that if we wanted. So we can do all sorts of great stuff with this now that we have our equation. Just to finish off the story, if we wanted to have figured out our intercepts this way, we could remember set X equal to 0 to get my Y intercept, divide both sides by 6, and we would have had Y equals to 8. And I could have started with my equation, 48 equals 4x plus 6y. And if I had said y was equal to 0, then I could have had 48 equals 4x, divide both sides by 4. So I could have easily have solved for my intercepts algebraically instead of how I did it up here by thinking my way through it. And last but not least, I can take my equation that I created there. Let's see, that was 48 equals 4x plus 6y. And to find my other points on the line, I can rearrange this into y-intercept form. So minus 4x, and you would get negative 4x plus 48 equals 6y. Divide everything by 6. And by doing that, when we get our slope y-intercept form, that'll help me figure out where other points are on the line instead of having to have graphed it. So that would give me, what's that, negative 4 over 6x plus 48 divided by 6, remember, is 8, equals y. Reduce that, negative 2/3 x plus 8 equals y. So we can go all the way around. All these different forms help us find all these great pieces of information. And there's my slope, so I could have used it to count down. Cool, eh?